Good morning, good morning, good morning. I am sorry that I couldn't be with you guys today, but I was invited to go to the eighth grade choice day at Poe. I am sorry that I couldn't be there with you, but I've got a lesson for you that I've got recorded that I have full faith that you'll be able to get figured out. It's kind of the same thing y'all have been doing over the past week and a half or so, all right? We've been looking at solving for the total surface area and the lateral surface area of a couple of different 3D shapes. We've talked about prisms, we've talked about pyramids, we've talked about a lot of things over the past couple of days. And we're going to continue that, all right? Today, though, we're going to be starting on cylinders. And these things, they're a little tricky, all right? First things first, I'd like to start with something you're pretty familiar with. I'd like you to help me by finding the bases on both of these images. Now, we're going to go through a couple of times where I'm going to stop talking for a little bit because I'd like for you to be solving. During that, the video is going to keep playing. There's no need to pause it or anything like that. I'll be silent for as much time as I need to, all right? But for this first example of that, let's go ahead and practice by shading the bases on both of these images, okay? I'm gonna give you about 30 seconds worth of silence as this continues playing, but let's see what you come up with. Shade those bases for me. All right. Let's talk about those bases, okay? Now these bases, pretty sure you got them right first try. Base on this one is going to be both of these circles. You know, the one on the top and the bottom. Kind of like a can, right? You set it on the shelf in your pantry. You're going to set it with the circles up and down so it doesn't roll off, right? A good idea, those bases. Now, in my classroom, I gave you another example, kind of loud when I knocked my cup over. You remember, I did that intentionally. I said, what's the base? You said a circle, and I knocked it over and said, now what's the base? Still the circle, right? Same thing here. It might be on its side, but we would still be able to say that these two circles here, those are my bases. It's important to be able to do that because once again, our lateral surfaces are the things that aren't bases. We have to find the area of everything that's not a base. Total surface area, we get to add the bases to the lateral surface area. So knowing what a base is, it helps us, right? What I'm going to go ahead and do then is I'm going to take these shapes, I'm going to take a set of scissors to them, and I'm going to cut them apart, right? What we're looking at here is the net of a cylinder. You see, you got the top circle up top. You've got the bottom circle that would normally be seen, but it's kind of hidden down here, right? Then you've got a rectangle. Well, yes. For those of you that have ever been drinking a soda, kind of bored, and you're like, what about taking this label off? If you had enough patience, you probably were able to get that label pulled off. And when you did, even though it was wrapped around the bottle, the shape of the label you ended up with was a rectangle, right? Think about those cans that are in your pantry. You got a bunch of paper wrapped around the outside of them, and that paper was printed flat before it got glued to those cans, okay? Those were printed on rectangles that were changed by being wrapped around that circle, wrapped around those bases. That's that rectangle we're talking about in the middle. Now, looking at this, I can find a couple of different numbers that go with this that would help us be able to solve for the area of each of these shapes. Like if I look at this line here, I know that one of the numbers over here goes there. That would help me with finding the area of the circle. I know that this arrow here, I'm running out of room, I apologize, would be another number over here somewhere, right? And then I've got one more number here that I'm going to be able to get from the numbers over here somewhere. What I'm going to do is I'm going to pause myself for about 2 minutes or so. I'd like for you to take these numbers over here and apply the numbers onto each of these arrows to tell me what goes where, okay? Like the 4, where does it go? Like the 10, where does it go? So on and so forth. Do the best you can. Maybe I'll shorten it to about 1.5 minutes. Let's see what you got. Yes, you do have enough to be able to solve for all of this. I promise. Yes, you can look at your notes from the test. One of the formulas on there is actually going to be helpful for you right now. About 30 seconds. Don't be afraid to bounce ideas off your neighbors if you haven't done so already. Collaboration is helpful when it comes to approaching a problem from a new perspective. Okay, I'm going to start with the one that you probably knew right away went where it went. The number 4. Like, let's face it, that radius right there, it's iconic. It goes halfway through the circle. It's on a circle. It's red on both of them. The 4 centimeters, it goes there. Yes, the units matter, all right? Units describe length, they describe area, they talk about volume. It's important to know what the units are, and you'll actually get a chance to see why in just a few minutes. The other one you guys probably already knew, the 10. The 10 talks about how tall this little cylinder is from bottom to top. If you think about it in a little bit more of a sciencey, nerdy kind of way, it's the distance that those circles are apart from each other. Like, they're just 10 centimeters apart, whether it's here, whether it's in the front here, whether it's in the back, like, you get the idea. The distance that those things are apart are 10, and if I laid this back down flat, this would wrap around and be, 10 tall. Now, I said something there that might have got your brain seeing something that you didn't catch the first time, that wrap around idea. Going around the outside of a circle, there's a word for that. And that word, it's a big one, but it's one you have to know. It is the circumference. That's the distance around a circle. And in order for us to be able to solve for the circumference, we're going to have to be able to know about pi. Because the circumference formula is 2 times pi times the radius. Well, my radius is 4. Like, for realsies, we can use that 4 to be able to solve for the circumference here. 2 pi times 4. Now, I don't have one of your fancy schmancy calculators. I kind of gotta go to the Google one. But in my case, the Google one is still gonna work just fine. So, when I look at this, I'm looking and saying, okay, 2 gets multiplied by pi, which gets multiplied by the number 4. I'm sorry for the bouncing. My hands aren't the strongest right now. That equals 25.132, blah, blah, blah. Look, 25.13 is enough for me. 25.13 goes here. And that's my centimeters. That's this length. With my big fingers, small screen issue, I'm not able to get that number fitting on that little blank right there. Do the best you can in your paper as well. Now that helps us be able to solve for the area. If we multiply these two, the 25.13 times the 10, that would give me the area of this rectangle, 251.3 centimeters squared, because area, since you're multiplying centimeters by centimeters, you get centimeters squared, like square footage when you're finding the area of the floor in your house. Same kind of concept here. Oh, and those circles. We can find the area of those circles too. I mean, seriously, if you think about it, we've done the area of a circle formula a couple of times. It is pi times the radius raised to the second power. So in this case, pi 4 squared, which is 50.27. I'm rounding to two places after the decimal. That 6.5 rounds up to 27. That was 50.27 and another 50.27 because that circle on the bottom's the same size. All we got to do is know what our lateral surface area is. All we got to do is add to that the area of my two bases, and we're good to go. Once again, lateral surface area is the stuff that's not a base. Like y'all shaded at the beginning, the circle is my bases. This is my lateral surface area. The 251.3 centimeters squared is my lateral surface area. Once I add the 50.27 on both of those, I've got my total surface area, okay? We would use our calculators for that addition. Let's go ahead and jump straight into our examples just now because, honestly, this concept here, I have full faith in your ability to apply it, to actually fill in the answers for these, okay? First and foremost, find the area of each of the bases. Sweet, so let's do that. Area of a circle. Why a circle? Well, because those circles are base, pi, times the radius squared. How about I give you all 30 seconds? Use your calculator skills. Find the area of one base. I say it like that on purpose because there's two of them and we'll be able to figure out for both of them in a second. Find for one. 30 seconds. Oh, sweet, you're done. Let's go ahead and check it. Pi r squared, pi 2 squared. Nice. Let's go ahead and grab that calculator back up in front of us. Let's go ahead and go to calculator. Let's go ahead and clear this. Pi times 2, come on, I didn't right click, times 2 raised to that second power is going to equal 12.57. Sweet. Each base is 12.57 centimeters squared. There's two of them. So that means I'm going to end up needing 2. We'll talk about that in 2 seconds. Let's find the area of my lateral surfaces now. Once again, lateral surfaces, that's that rectangle here that gets wrapped around. Now the height is 6. Sweet. I got a bit of a problem though. Like, I need this amount here. I'm going to give y'all about 30 seconds to replicate what I gave you earlier today. And let's see if you can figure out how long that line is. I'll give you a minute for that. Use your neighbors. You can do this. 1 minute. Yes, you need to know how to find the circumference. All right, circumference. I gave you that formula just a little bit above. You know, the 2 pi r thing. I go to my computer and I say, okay, computer, okay, let's do this. Clear out my old stuff, refocus so everyone can see what's going on. Let's see if I can brace my hand so it's not so shaky. Don't think it's helping. Pi times 2. It's actually 2 pi 2, excuse me. Let's go ahead and clear. 2 times pi times 2. And for that, I get 1256. That's the same thing. That's the same number. And that's intentional. Having a radius of 2 is the one time that you're going to find that the same number gets sent out of your calculator, okay? It does not mean the same thing, though, okay? Once again, when we're talking about area, we're talking about filling up a 2D shape with color. Like painting it. Like if I gave you a can, could you color the top of it if I gave you some paint? Yes, and it would cover length and width. And that would be my area here. It's like the floor, the length and the width. You can fill it with some tile and you're going to be able to find the area of that. But circumference is going to be a measure of length. It's like if I gave you a piece of string and said, tell me how long that piece of string would need to be to wrap around this can one time. The length of that would be 12.57 centimeters. Not centimeters squared, just length. So while the numbers look the same, because the units are different, they mean two different things. I'm pointing that out because I've seen people get confused from that even in the high school level. But it's okay that the numbers came out as the exact same number from the calculator. This is the one time that will happen, is when the radius is 2. We need to find the area of that, and that's honestly not that bad. Rectangles, y'all have gotten redonkulously good at solving for area using rectangles. It's just length times width. It's just base times height. So I take that 12.57. I multiply it by the 6 that was the height that we were looking at, and I get basically 75.4. And I'm going to use that as the area of those rectangles. 75.4. Hang on. Lateral surface area. Lateral surface area. That's the area of the stuff that's not a base. Like circle's a base, the other circle's a base. The only thing that's not a base is that rectangle. 75.4 centimeters squared. I'm out of room. Like I said, small screen, big fingers. It makes me run out of room pretty quickly here. All right. That's my lateral surface area. To find the total surface area, where I put everything together, I need to add to that. I got to go, okay, I got 75.4, but I've also got 12.57 and 12.57. Why? Well, because each of those circles, this one on top and that one on bottom, have that same area there. I add these things together. I go, okay. I have I forgot the number. I apologize. 12.57, okay? So I go 0.57 plus 12.57 plus, that 75.4 that we just had. We're going to add that. And we go, okay. All together, I've got 100.54. All together, like total, I have that 100.54. Yes, that is going to be my total surface area. Don't forget that's centimeters squared. I'm out of room again. I apologize. Now, I'm leaving this on the screen. Like, you're going to hear me as I'm like moving around in the background and such like that for like the next 3 minutes. But for those 3 minutes, this picture is going to help guide you through the next question that's on the back, which, let's just say I'm trying to be a little tricky with, right? If you know, you know. Help your neighbor out. 3 minutes, solve that last one. 2 pi r. 2 pi r. Hint. Hopefully you've already seen it, but that R letter is important. By this point, you should be able to have the area of those circles already figured out. You may need to find that missing side of that rectangle side. Sorry about that. When the screen turns off, it decides to stop recording. I didn't touch the screen for a little bit. We're still going. We're still going. Like I was saying, circumference formula, that 2 pi r thing, probably going to be useful for you. You should have your length and your width for that rectangle and should be solving for the area of that rectangle now. You should have your lateral surface area and be adding it to your total surface area, or to your area of your bases. And you should be done. We're going to go ahead and run through this. It's going to go very, very fast because I have full faith in your ability to do this. Okay, first off, first thing to pay attention to, that's 6. Like I said, the R, very, 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 very important. That's 6, problematic. I only need half of it. Diameter goes all the way across, radius only halfway. That means I need half of 6. 6 divided by 2 is 3. So my radius is 3. To find the area of each of the bases, it is pi 3 squared. Now, once again, I'd like to throw my calculator back up on the screen. I apologize. Again, I clear everything. I go pi times 3, raise it to the 2 for pi 3 squared. It didn't do it. I apologize. Raise it to the 2. That equals 28.27. Okay, I'm going to go ahead and document that. 28.27. Now I'm going to find the rectangle thing. The rectangle thing, how long, how wide. When I look at that, I see the 8. I also need the 2 pi r, or in this case, 2 pi 3 thing. That 2 pi 3, remember I told you 2 is the only time it was going to be duplicated. You'll see that if I go 2 times pi times 3, that the number we're getting is different. Like I said, 2 is the only time it matches, 18.85. So I put my 18.85 here. That is the length of this side. To find the area of the rectangle, I take my 18.85 that I have here. I multiply it by the number 8, because that's the height between those two circles, 150.8, okay? 150.8 is going to get added to the area of my circles, which, because I don't have it on my screen, I gotta check again, 28.27 Okay, so I go plus 28.27, and that is going to be 179.06. For those of you that are complaining right now, I know why you're complaining. I didn't add the second circle. How many of you actually caught that? How many of you realized that I only added one circle? You have to add both. That mistake right there is something that, again, I have seen too many people make. They only add one base. They get a number that's a little bit off, and it messes them up, okay? Make sure you know how many bases you are so you know you need to add it twice. Now that I've added it twice, the 207.34, or 207.34, that's my total surface area. The number that I had from before is going to be, where's my history on this? Doesn't let me scroll up. It does not. Actually, it does. The number I had from before, the 150.8, is my lateral surface area. That's where I did my 18.85 times 8, and that's where I got that from. Now, you've got a worksheet. I'd like for you to go ahead and complete it. Yes, it's only one side. You got this. Promise.